name is Andy Wigley. Some of you may have seen me on Channel 9 doing some videos. I've spoken to a couple of you out there who have seen me on the Microsoft Virtual Academy and also on Channel 9. I've done a load of instructional videos for Windows Phone 8 application development. We did the Jumpstart video series, myself and a good friend and colleague, Rob Tiffany. And I've also done the Windows Phone 7.1 Jumpstart before that with Rob Miles. And we good? Yeah, thank you. And so I've done a load of these Jumpstart videos, so hopefully some of you have seen that. If you want to learn about any aspect of development for Windows Phone 8, there is a video in there for sure, because there's like 20 hours of it. It's a lot of stuff. This session is it's called the Networking Survival Kit, and it's kind of a collection of all the stuff I've learned building Windows Phone 8 applications, all the kind of tips and tricks and some best practice in there. So it's going to be a real breakneck-paced, fast-paced thing. So you're going to need to hold on to your hats, because we're going to go through a load of stuff. And the agenda is looking like this. First of all, about how we can use async and await for HTTP program, which is something that's not supported out of the box in the Windows Phone 8 SDK. And then about good design practices, about thinking about how much data you're transferring over the wire, and what the serialization format you're using is. And coupled with that, of course, is how to use compression. This is a topic I'm passionate about, and most people just don't give it a second thought. Obviously, if you're accessing services, credentials come into it. So just a very short little couple of slides on how you handle credentials securely on the phone. Well, one way of doing that. And then I'm going to look a little bit, and then we kind of start scattering our attention to a few other sort of related things that not closely related, but in the networking area. First of all, how you can make use of SkyDrive for storing stuff. It's really easy to program, and there's a real good value in doing that. And then something that I'm sure many of you have tripped over is actually we get this great emulator in the Windows Phone 8 SDK. And if you're developing networking applications and you're creating a service in Visual Studio 2012, and you've got your client running on the Windows Phone 8 emulator, you would think it would be easy to connect to it, wouldn't you? It is not. So this will just talk you through the process of getting that to work, because it does trip a lot of people up. And then finally, a little bit of fun at the end. Just have a quick look at some of the stuff you can do with NFC and Bluetooth. So hopefully, my goal is to send you away from here being a fledgling Windows Phone networking guru. First of all, now, this is our message for this show for Windows Phone 8, that Windows Phone 8 is absolutely ready for business. And we've got the great, obviously, the consistent experience between Windows Phone 8 and Windows 8, all the great built-in applications, the Office 365. And this is where kind of the networking side, where this talk kind of fits in. It's a robust platform for mobile apps. It's a great platform for building mobile applications on, especially when you start applying all this stuff I'm going to be talking about. And, of course, we've got great app and device management. So really, Windows Phone 8 is a great platform for building your business enterprise apps. OK, so into the content of this talk. Can we get this clock running down? OK, great. So, the first topic, HTTP programming with async and await. How many of you here have already programmed with async and await? Yeah, that's kind of like half the room. That's just kind of fairly typical. Obviously, it's growing, and people are starting to get experience with it. It does take a little while to understand what's going on. But what it is, async and await, is this new programming style, if you like, for doing anything that's kind of asynchronous and long-running. Came in with C#5. It is in Windows Phone 8, the kind of task support, the base class, the methods and everything to make all this happen. And what they did with Windows Store apps for Windows 8, they went through when they were putting together the .NET libraries and the WinRT libraries that you're developing against on Windows 8, they had a look at every method in the API, the core libraries set, and anything that would take more than, I always forget the exact number, it's either 50 milliseconds or 75. Anyway, anything that's kind of a lengthy method, they would make it async. It was the only way of doing it. There was no synchronous method for calling it. So the point is that async methods cannot block your UI. And it's all about making sure that the user has a really good experience and the UI isn't stuttering and your animations are fluid and all this kind of stuff. So it's a kind of programming pattern that enforces that you can't accidentally block the UI, which you can do accidentally with the older styles of programming these things. So yeah, in Windows Store apps, we've got new APIs, HTTP client. And one that you may recognize from Windows Phone development, HTTP web request, that still exists on Windows 8, but they've just changed the methods, the API surface, if you like, and there's only async methods in there for making calls to it. Now, in our flavor, it's still asynchronous. You cannot make a synchronous HTTP request in Windows Phone. There's no way of making the request and then blocking until you get the response back. There's still event-driven, or there is a callback methods, but not using this new async style. So if you want to get all your code being the same across Windows 8 and Windows Phone 8, we want to have a consistent experience. So probably we're going to want to use async and task-based methods on Windows Phone as well. And they're not available. They didn't make it into the Windows Phone 8 SDK. But we have now got some solutions. So first of all, HTTP client API. There is an implementation of that was released last week. It's developed by the .NET Core CLR team, the .NET Framework team, and this HTTP client is available on NuGet, and that is supported on Windows Phone 7.1 and Windows Phone 8. If you're using it on Windows Phone 7.1, you need to add another NuGet package, the bcl.async, which gives you the async support. Adds that into Windows Phone 7.1. So you can actually have consistent networking code across all the platforms now. And we also, if you want to use the web client and HTTP web request, but you want to adopt the new async model, we've got extension methods that people have developed that gives you that behavior and allows you to use that pattern with these APIs as well. So just to summarize what we've got obviously the web client API, which I'm sure many of you used, is available on Windows Phone 7.1 and again on Windows Phone 8. Actually no change out of the box with our networking APIs between Windows Phone 7.1 and Windows Phone 8. So web client, not available on Windows 8. HTTP web request is available across all the platforms, but actually there's slightly different flavors of it. Like I said before, on Windows 8 is only async methods, whereas we've got the older style of calling it on Windows Phone 8. HTTP client, well, it used to be cross under Windows Phone the previous time I gave this presentation. I now can happily say, yep, we've got that, but only through NuGet, so not out of the SDK. But now we've got consistent story across all the platforms. And then going down, you can see that on Windows 8, we've got a couple of convenience APIs, syndication client and the AtomPub client, and make it easier to access those. And good support for web services across the board, ASMX, WCF, and OData. So what is this async I'm going on about, and why is it better? Well, let's look at the old way of doing it. This is an example of using the web client API, so this is probably the kind of networking code you may have written up to now. You new up an instance of web client there in the constructor of main page, and then you need to hook up an event callback, an event handler that's going to be invoked when an operation completes. So here we've got download string completed. There's other ones. There's download file completed and upload string and upload file completed ones as well. But in this case, we're just going to pull a string down from the remote server. So you hook up an event handler for download string completed. So that's that method in the middle there. And then at some point later on in your logic, in a completely different place, down here in the load button click, we actually then finally make the method call that's going to make that request, download string async out to some URI. And like I said, it's only at some point later that it will call back on the download string completed on some random thread, and if you've got an exception, it kind of makes it messy as well. And that's the point. It's messy. It's like stuff all over the place. That's the equivalent using async. It looks like synchronous code. And this is why it's so nice from the developer point of view. We're newing up a web client, and then we call response await client.downloadString task async to the URI, and then we handle the response. Brilliant. Isn't that great? It's nice and clean and easy. Now, there's a lot going on here, actually, under the covers. So when you see, when the compiler sees this method, what it actually does, any method that's marked with that async keyword, and you have to put that on the method signature if you've got any await calls within the method, that's enforced for you, and the compiler will make you do that. So what the compiler actually does when it compiles this is it reorganizes this. It compiles this actually as a state machine, right? And what happens is, as it goes down at runtime, what will happen is it news up the web client, and then we get to the next line where it says await clients.downloadString task async. Now, what actually happens at that point is the download string task async bit of it is spun off onto a background thread. And this method here, it actually just takes a snapshot of the state this method at this time and saves that on the stack, and then it actually suspends this method. And so your UI stuff and other things, user can still be interacting with the UI and scrolling lists and all the other stuff that your application may allow them to do. It's totally non-blocking. But out in the background, this method is executing. And when it completes, then the response is put back into that string response. That's the return value from calling that method. And then you just carry on and execute the next line. This.downloaded text equals response. And you'll see that although it's actually executing on a background thread, it's not even obvious to you as a developer that anything's happening on a background thread, because it's just taken care of for you. And if there's an exception while you're calling that, like they cannot get the connection or something, or the drop connection, the exception will be thrown back on the originating thread. It's marshaled back automatically to where you called it from. The same way that the response has been marshaled back to where you called it from. So you don't have to worry about code handling the callback that might be on a background thread and doing all this dispatcher.begin invoke stuff. It's all just done for you. So it's really cool. It's really a nice way of programming this sort of thing. This is an example of this is the HTTP client. This is the one that we've got in the NuGet package, which is now available. And this is common. This is exactly the same networking code you will have on Windows 8. So HTTP client, you new up an instance of that. If you want to handle a compressed payload from the server, and like I say in the comment, why on earth would you not want to do that? Because I think definitely you should always support compression if you can. So there's you can put a handler into the HTTP client, and then you can set some headers, and then finally you call HTTP client.getAsync, and it's the same kind of pattern as before. Just handles it all for you, and then when the response comes back, there's a nice method on it called ensure success status code, which basically looks for an HTTP 200. And then you can just handle the response body as text. And you'll see there, we've even got a read as string async, another asynchronous method. So anything that kind of might take a little bit of time tends to be asynchronous these days. And particularly like networking stuff, reading and writing to files, and big string processing, this kind of stuff. So we have the least exciting demo you will see or show, where I just proved to you that is actually the case. So this is the HTTP client. I've got it in my phone application page loaded, and surprise, surprise, it's actually the same code you saw on the slide, more or less. I'm just going to put a breakpoint on there. We'll run this in the emulator. So when the page loads, it will be making that call out to that Northwind service. Here we go. We're now to make the call. I'm just F10 to step through that. There was a bit of a pause. It's come back. Have we got a good status? Yes, we have. So we write that to the debug, which is OK down there. And then I'm using JSON.NET to deserialize it, because actually what we've got back is response body as text. That's actually all the JSON we've got back from that service, so JSON format there. So we're deserializing into objects, and then we're just putting up a message box. I'm going to let it run now. Hit F5. Message box just tells us how big that payload is. I shall be coming back to that in a demo later on. And there we are, just sticking it onto the screen. So these are all some of the data from the Northwind database that we've pulled down from a service. So, like I said, spectacular demo, huh? Anyway, that was that one. I've got another one on here. This is like an example of this is the web client. In this solution, I've got two versions of this. This is the old style of doing it, where we've got, here's the new up the web client and hook up a download string completed. This is where we actually do our handling of the response there. That processing is all down there, and this is where the request is actually made. So it's kind of all over the place. And the nice, concise async version of that looks like that. There you go. So much nicer, much neater code, easier to maintain as a developer. And actually, once you spend a bit of time figuring out this awaits and task stuff and what you can do with it, it's really quite relatively simple, straightforward to program. Sure. So the question was, can that compression handler allow you to handle in credentials? So I think the HTTP client must have a different way of doing that. I don't know the answer to that, actually. I actually don't know the answer to that, so I'll have to get back to you on that. Yeah. So that was async. That was the first bit out of my nice networking toolkit. The next thing is talking about being smart about your networking as well. Making smart decisions about it. So this is all about, I mean, at the simple level, making sure your application is aware of changes in the network status. So you want to try and give great user experience as much as is possible. So you can actually find out whether you get a network is being dropped or you're getting a network back by subscribing to the network change event on the network interface type object, and that will give you an event whenever you gain or lose a network. So at least then you can start putting some information feedback on the UI of your app to say, oh, lost network or something. And it would be a better experience if when the user taps on something that would normally start a network operation, instead of it sort of pausing for 30 seconds and then you putting up, hopefully you've caught the exception, the timeout or something, and then only then giving an error message. Well, just tell them straight up front, I'm sorry, we've got no network. So you don't rely on the the actual call failing. And coupled with that, there's all these APIs you can get information relating to networking. The top ones there are fairly not terribly interesting. You can find out who your mobile operator is. Is network available is quite interesting, but that's so this is allied to that event we were talking about on the previous slide. And then there's a couple of others about cellular data enabled, roaming enabled, Wi-Fi enabled. Those go back to the settings on the phone, what the user has actually set. But the one at the bottom is more interesting, network information.get internet connection profile. This is one of the new APIs that's in the Windows runtime. So this is common. It's a subset of the functionality that's available on Windows 8, but this API is available on Windows 8 as well. And you can use this to determine what kind of network you are on. Not sadly, and I've been asked this quite a few times, not sadly how good the signal strength is. We can't get that. But at least it will tell you whether you're on Wi-Fi or whether you're on cellular. So you do that by calling windows.networking.connectivity.networkinformation.get internet connection profile, which will give you back some kind of an object, unless if it's null, you're completely offline. But if we are connected to the internet, you will get an object back, and you can look at this IANA, I can never say that, interface type. And there's if you look at the documentation, if you go to the docs for this, it will point you to something on the IANA, which is an international networking authority website, and you'll find a great long list of these interface types. There's about 240 of them. We're actually only interested in a few of these. Other essentially means we're on a cellular data, and then Ethernet, well, probably doesn't really apply to a Windows Phone device. Moment, and then Wi-Fi, of course. So the interesting ones are other and Wi-Fi. So if you get Wi-Fi back, you know we've probably got a good, fast, high bandwidth connection. So you can actually start doing some fairly substantial network transfers. But this is where you use this information to sort of, if you are wanting to do a big network transfer and you find that you're not on Wi-Fi, you probably want to block that to the user and put a nice message up saying you'll need to connect to Wi-Fi before downloading this. Again, it's all about giving the user a great user experience. And you need to use this information to keep them informed about the state of the networking of their device. And I get quite, uptight about this because there's kind of this myth in the mobile industry. I mean, we've all read about 4G LTEs being rolled out across the nation and across Britain at the moment, and and it's everywhere. No, it's not. It's in a few major metropolitan centres. Outside of that, you want to try and come to where I live in North Wales, in the mountains. It's a beautiful place, but the phone connectivity sucks. So, and this is a fact of life. And even in a big city, or, actually, it's pretty good at this conference. Normally, when you get so many geeks in one place, all connecting to the same network, and they've got like 2 smartphones and a tablet and a laptop, and they're all connected, then we start running into problems. But actually, it seems to be pretty good at this show, but I've been at plenty where it's not. So the reality is, you've still got to design for poor quality networks. And you can do a lot to help yourself here. If you own both ends of the link, so obviously you're writing the client software, let's assume that, but maybe you're able to create the service side as well, well then have a think about what you're transferring. So too many people are lazy about this, and they transfer loads of data from the service, because it's kind of easy just to throw everything out, and all this data goes over to the phone, and then the phone uses like 5% of it. Well, where's the sense in that? It's costing your user money for the actual data that's being transferred, but more importantly, it might actually, because the network transfer is unnecessarily bloated, it might actually cause it to fail completely, because it's on a poor quality network, and it just times out before your user loses patience. So you can help yourself here. Only transfer the data you need and use really good serialization. And even if you don't own the other service, you can actually consider putting in your own service as a kind of a proxy, as a gateway. And your phone app will make calls to your service, and your service then makes call onto the third-party service, gets the response, models the data in some way, reformats it, it throws away the bits it doesn't need, and then sends back only what you do need. Now, obviously, that's a cost, and you have to factor in whether that's a good idea, but you can do stuff like that. I've got a great demo that really drives this home. So let's go and open the next solution, which is this guy here. All right, so this solution has got two projects in it. First of all, there's a web service, and it's actually a WCF. It's an OData service. Oh, you're not seeing it. Thank you very much. There you go. So this solution has got two projects in it. Yeah, a WP7 core web services, which is this guy, and a web service. This is an OData service. So actually you can view in the browser, which initially will fail. It'll say an HTTP 400 bad request, because this service has been configured to allow remote connections. So let's go, that's Rockstar, this is the name of this thing. This is the root of the Northwind database. So I've got an OData service that exposes the Northwind database. How many of you have worked with OData before? Just a couple, okay. Right, OData's great, it's really cool. It has a few rough edges, as I shall explain. But the thing is, it's to actually create a WCF data service, an OData service, to expose a relational database such as this, actually can take as much as 10 minutes of time. And you've got a service ready to go. Okay, if you add a bit of security and stuff like that, it can take a bit longer. But it's very easy to create a service like this. And this is the root. These are the tables in the Northwind database. So if you want to actually then have a look at what's in the suppliers table, you can just change the URI. And this is just HTTP GET. It's a RESTful service. So you're just using HTTP calls to actually get information from it. So here is all the data. Let's just make that a bit bigger. And this is all of the suppliers' records. In actual fact, this is the actual data down here, the properties. And you can see that this is application/XML format. It's all XML. This is actually an atom feed format here. You can see the atom feed. And you get not only the data, but you get a lot of kind of contextual data as well. And you get cross-references. You see all these links here, link here, and this link here. These are all information to the client on how to navigate the relationships between records. So if you only want to look at just this supplier's record and not all the others, it actually tells you there that you just need to change the URI to 7. And there's just the 7th record. And if you want to find out what products this supplier has, then it actually tells you what you need to do. You just need to change the URI again and put /products on it. And there we go. Now you get all the products that this supplier has. And you're just navigating very easily through the collection, which is really cool. And it's a really nice way of creating lightweight data services. So it's good. And this is one format that an OData service or WCF data service exposes on the wire. What you're seeing here, of course, is XML. But it also supports JSON out of the box. So this is where the client comes in. So I'm going to run the application. And we'll see the code in a minute, because I've got loads of breakpoints in here. So we're going to make a call to this exact same service 4 times. The objective here is to get the supplier's data down to the phone, okay? So first of all, I'm going to make a call requesting the full fat version, if you like. This is using a web client. I'm using download string task async off to my service URI there. And if we just hover over that, you can see what we've got back, which actually is exactly the same as we were looking at in the browser just then. So we've got all the link stuff in here and all the data and all the rest of it, and that is all it is there. And if I let that run, you'll see that, let that run, go, then it's actually, we're seeing how many characters that's actually on the wire. Is it how much data is being transferred towards in order to transfer that data to us. So you can see we've got nearly 29K if you're using the Atom feed with all that link stuff. The other format it supports is JSON. So I've changed all I've done here is I've set an accept header on the request, and I've said, can you give me application/JSON format, and I want the verbose format as well. So what that gives us is exactly the same data we had previously, but instead of XML, this is in JSON format. But essentially, we're getting exactly the same, all the same data coming over. And that one is quite a lot more compact. JSON is a lot more compact than Atom feed. So there we go. We got 15K. Right. Now, in WCF Data Services 5.1, which came out about 6 months ago, a new format came out called JSON Lite, or was known as JSON Lite. And if you want JSON Lite, and actually this is now the default for WCF Data Service, you just leave off that OData equals verbose bit. So you just ask for that. This time, what you get is just the data. So all those links, all that cross-reference stuff isn't there. Which, if you don't need it, don't send it. You know, all we want is the supplier's data. So this is just the supplier's data. So there it all is. And the size of that, 8K. And the final one is exactly the same thing. It's JSON Lite, but before we've sent it from the server, I've gzipped it. So it looks a bit like that. So there we go. And that one, 4K. So there you go. It's exactly the same information we've got down to our client application. You've got a choice of doing it at 28, nearly 29K or 4K. So which would you choose? It's kind of no-brainer, really, isn't it? And there is a slight, you know, with compression, there's a slight overhead in actually doing the decompression on the client. But I think in terms of the overall user experience and the time required to actually get the data from the server to the client, absolutely, totally justified. So that's just a summary of what we just saw. And that's just with one service. Now, this actually takes me nicely on to the subject of how do you implement compression? How do you handle compression in a Windows Phone application? So the first thing to say here is actually there's no support in the base class libraries on Windows Phone 8 for decompressing a stream. On Windows 8, we've got the system.io.compression.gzip stream class, which is very nice. But like I said, we don't have that. So you have to use some third-party solutions. And there's a couple. Sharp ziplib is very popular, and Sharp compress. And there's NuGet packages for at least one of them anyway. And also on NuGet, this is very nice class thing you can download called the gzip web client, which is exactly the same as a web client, but handles all the compression stuff for you and uses Sharp ziplib internally. So you can just, it's exactly the same API, just instead of newing up a web client, add a reference to NuGet and then pull this, use this other one instead. So it's a real easy implementation. Now, what do you have to do on the client side? So I'm using an HTTP web request as an example here. So from the client side, in order to handle compressed data, and as you know, of course, HTTP is a request-response protocol. So every transfer starts with the client making a request to the server, and the server sends something back. So on the request, you have to tell the server that you are happy to receive zipped content. So you do that with the accept encoding header. gzip web client does this for you, but if you're doing it manually, this is what you have to do. So you can set the accept encoding header to gzip, and you'll often see deflate, but we haven't got a solution for that. So set it to gzip. And what you're saying to the server here is, if you can zip content, I can handle it. So send me zipped content. It doesn't mean the server necessarily will, because the server's got to be configured for sending zipped content. So then we make our request.getResponse async, and we wait for our response to come back. And then when we get our response, what you need to do is look at the content encoding, which is another one of the HTTP headers. So you can just get at that directly through the response.content encoding property. And you need to look to see whether there is gzip in there. And if that is present in the content encoding, then the server has sent you zipped content. It may not have done. So that's why we've got that if-else then around that. So if it is gzipped, then you need to pass it through a gzip input stream to decompress it. If it's not, then, well, we just take the stream as is, because it's already decompressed data. And then we can read the data out of it, as you can see the rest of the code there on the slide. And what happened there? Okay, all right. And this is, I haven't shown you this API, but this is just because this is my toolkit, and you're giving you everything you might need. With OData services, there's actually two ways of accessing them. So I showed you doing raw HTTP request using the web client API in that demo I just showed you. But there is actually another API, which is a kind of link-based, higher-level API, which allows you to access objects from an OData service, just the same as if they're in memory. So this kind of, it's often known as link to URI, but it's a client-side OData client library, and is a different style for accessing them. If you end up using that, then this is how you enable the handling compression with that as well. There's two events, writing request and reading response. And on the writing request, that allows you to add something to the outgoing requests. So in that case, we're simply setting the accept encoding HTTP header. And then on reading response, that allows you to intercept the incoming data and do some processing on it. So there we go. Again, we're looking for the HTTP headers, including this content encoding. And if it's got gzip, then you pass it through a gzip stream. So that's just for completion. I'm not going to show a demo of that. So on the client side, as you can see, it's fairly straightforward. But the real fun comes if you want to test this out yourself, you're doing your own development, then you'll need to set up your IIS-8 to do compression. So this is on your Windows 8 development PC, where you're doing your Windows Phone 8 development. And actually, configuring IIS-8 to compress is a whole lot of fun. First of all, you need to, the reason why it's a whole lot of fun is that what you get with an OData service is something that we call dynamic content is being passed back. So you send we're changing the URI slightly, and the content, the response that's going to get sent back to the client will vary according to what's in the database. So it's dynamic. So the first thing we need to do is make sure in the Windows features, so you go into the control panel, go into turn Windows features on and off, you need to check the performance features. You have to drill down into Internet Information Services, World Wide Web, drill down to performance features, and you need to check the static and dynamic content compression. If those aren't checked, nothing will ever get compressed. That's the first step. And then you need to go into IIS Manager, and you need to do some configuration on the server. So you select the top line in the Connections window, and then in the feature window in the middle there, first of all, there's the compression feature. So you need to go into that. And again, there's another enable dynamic content compression checkbox in there. You need to check that as well. And we're still not done. Because then you also need to go into the configuration editor in the features view. And I'll show you all this in a minute. Into there, and in there's a whole bunch of settings you can change, loads and loads of stuff, including, if you drill down into system.webserver, underneath there is a section called HTTP compression, and in there you need to add into a collection called dynamic types all the different types that you will want the server to compress for you, which in our case are the 4 on the bottom there. Those are the 4 that an OData service might return, but obviously that bit of it is service specific. Now, if you think you might have done all that correctly, it's actually very difficult to see whether you have done it correctly, because it kind of, it's happening on the wire, and it either works or it doesn't work, so you don't really know. On the client side, you're going to get out uncompressed data in your code, so you need to sort of have a look on the wire to see what's actually happening, and Fiddler is a great tool for this. Fiddler is a sort of network sniffer, and you can watch what's going on between your phone device and the server. But even that, you have to do a little bit of configuration because you need to configure it as a reverse proxy. So Fiddler will intercept any calls coming from your client software and then reroute them to the server. And while it's doing that, it can measure what's going on. So in order to make that happen, first of all, you need to go onto the Connections tab, allow remote computers to connect. That's one thing. And then on the Rules menu, you need to go and add this redirect clause to the end of a method called onBeforeRequest. So onBeforeRequest executes every time Fiddler intercepts a request. So what it's looking for is anything that's been sent to the PC on port, in this case, 8888, and it reroutes that to port 80. And then in your client code, you simply, while you're testing this, instead of sending it to port 80, you send it to port 8888. And these moving parts, if you get it all right, and it all works. So let me put that into pictures. Right, so we're done with that guy. And so first of all, let's go into the IIS Manager. Can you even spell it right? Then it might find it. There we go. So this is, I've already enabled IIS. Actually, IIS 8 isn't even installed by default on Windows 8 client. So you have to go into Add Windows Features and enable that. And I've enabled the dynamic compression in the Add Windows Features on and off. But then this is where this is all my, all my websites on this server, the stuff I've got on here. But at the top level, we want to configure the server. So you go into compression first, and this is where you need to check these guys. Clearly, I've already set this one up. And you need to check those. They'll be unchecked by default. So that at least enables IIS compression. But then we need to go back to the root here. And the other one I was talking about is this configuration editor down here. And this allows you to get right down into the low level of the IIS server configuration. And there's stacks of stuff. You can see all the stuff here. But what you need to do is drill down into system.webserver and find this HTTP compression, and this will give you all these settings around compression. And the dynamic types, this is the one. You see it says count equals 9. So this is the collection. Oh, hello, Mike. Got a tweet from Mike there. This is the collection of types that are being compressed by the server. So by default, you get these ones down to here. So by default, it will compress text, it will compress message, and it will compress JavaScript. But this one, look, everything else won't be compressed by default because that's the catch-all, and the enabled is false on that. So what I've done is I've added these 4, which are the types that are exposed by my OData service. And you could add types like this. You simply say, yeah, okay, I'm going to enable it to true, and then you put in the application. And then you put in the MIME type of whatever it is. I'll do a dummy one. So there we go, and then I'll remove it again. So this is all the moving parts. And then, having done all that, I'm not going to save that because I haven't changed anything. So that's the IIS side of things. And then I've got this thing, Fiddler, so we can see what's going on. And this is Fiddler. And in the Tools menu, you have to go into Fiddler Options, go to Connections. You need to check that, which is not checked by default. This allows remote computers to connect. And why are we checking that? Well, this is kind of a preview of something later in this talk. The Windows Phone 8 emulator is a Hyper-V machine. It is a completely different computer. It virtualizes right down to the hardware. So it's not a sort of soft simulator. It is a virtual machine running the full Windows Phone operating system. That is a remote computer, so we need to check that so that we can intercept requests from it. And in addition to that, you need to go into the rules. We need to go into Customize Rules, and here we go. These are all the rules. and lots of methods here, lots of stuff. And then what you're looking for is, here's some functions that execute at various bits of the life cycle of Fiddler on detached. Here's on before request. This is the one. And this is all the stuff that will be in there by default. And what I've done is I've added, at the very end of it, I've added this reroute connections from remote host to port 80. So anything that comes into this machine on 8888, I'm going to send it out again on port 80. So that's Fiddler is all set, and we actually got nothing happening at the moment, because then I'm going to go and find my sample. And here's the compression sample, and this is a very simple little sample. Run that on the emulator. Now this application, it's going off to the suppliers again, but it does it in two ways. And we can, first of all, we've got compression off, and then we can turn it on. So I'm going to do it first of all with compression off, and we're going to go off and fetch our content, and we get our received payload, and there's our content. If we go look at what Fiddler picked up, there's our request, and if we go off to transformer, you can see that the response body sent back was 17,002 bytes, and there was no compression applied. And now we go back to our application, and now I'm going to turn on the compression, and actually just to show you what that's actually doing. All it's doing is, the compression off is using the web client, and we're asking for the verbose thing, and then we're making the call to the service. And this one is using the gzip web client, which is the one out of the box. I've added that from NuGet, and that is also asking for the same data. So I've now turned on the compression, so I can, did I do that? Yes, we got compression on. And now I'm going to refresh again. It's going to go off to the server. Well, it still says we've got the same number of characters. That's because I'm doing this message box is being put out after the response has been received and has been decompressed. So this is the thing. You don't actually know whether it's worked. But if we go off and look at Fiddler, you can see it's got 3998 bytes on the wire, and this time gzip encoding has been applied on the wire. So you can use this to watch what's going on and make sure that you've got everything set up and compression is working properly. All right. What's next? A little bit about security. So, obviously, what we've done so far, we've made sure our services are efficient, and we're using compression. That's all very good. But now we also want to make sure that the data we're sending is secure. Now we can obviously use SSL TLS for that to encrypt data comms with servers that have an SSL server certificate installed. And the way that works is that the server has the cert, and then the client has to figure out whether that cert is genuine. And the way that works is the cert is issued, the server cert is issued by a few well-known and trusted bodies, Entrust and VeriSign, and others, GoDaddy. There's a few certificate authorities that are heavily regulated, and they are bona fide organizations, and they issue these server certificates. And the root certificates for these CAs are actually pre-installed into Windows Phone 8. So it means that whenever your Windows Phone 8 hits a service that's been secured with a bona fide server cert, it will be able to verify it against the root cert, and it'll be able to confirm that it's genuine, it's not been tampered with, and we're good to go. So we are actually verifying the server that way. You can install a self-signed certificate. If you're doing your own development, you can set up a Windows Server box as a CA. You can create your own server certs and slap them on your IS service. But then you actually have to go and transfer the certificate file onto the phone, and you just have to open it in some way. You can send it weirdly on an email, or put it on a share, or just open it and this sort of thing. And then that will install the root cert of your own self-signed cert onto the phone. That's kind of more for a test scenario. And as well as encrypting the data in transit, you're going to also need to authenticate the client. So all that the encrypting the SSL does is make sure that sniffers cannot intercept the data that's being transferred from A to B. But on the server side, and anybody can access that service, it's a public service, unless you secure it with some kind of credential request, and then validate the credentials to make sure that they are authorized to access whatever it is the service is offering. So if you're going over the internet, you're going to need to use basic HTTP with Windows Phone 8 applications. And if you're going to do that, then the actual username and password with basic HTTP goes over the wire in clear text. So the golden rule, the absolute non-negotiable rule here is if you're going to use HTTP basic, you must use SSL TLS, because otherwise somebody sniffing the network can get those credentials. If you're on the internet, we've got good support for Windows, a digest authentication as well. We've got NTLM and Kerberos. Now, from a coding point of view, dead easy. So here's an example of an HTTP web request. You simply new up a credentials object and put the username and password in there, and there's another one where you can specify a domain. That automatically attaches that to the HTTP web request, and the underlying class will take care of presenting those credentials when the credential challenge comes back to the client from the server. So you just need to you need to supply those credentials somehow, and this is where you need to start getting a little bit smart as an application developer, because you're going to need to put some kind of UI up to ask the user to enter their credentials. So that's fine. But if you're making lots of calls, you don't want to be popping this pop-up and asking for the credentials like 5 times every minute, because your users ain't going to like that. So you need to come to some kind of, a reasonable time when you're going to re-challenge the user to enter their credentials again. Maybe never. Maybe you just put the credentials into the settings and then save them securely, and then they're presented. And if at some point later on, when you call the service, you get a not authorized response back, then you'll challenge the user to enter updated credentials. That's how, email works, for example, on Windows Phone. If you've got, as soon as you've changed your password in Exchange, then it will pop up on the phone and it will ask you to enter your new password in. But if you're asking for credentials, you need to store them, and the credentials are secret. And this is true of any secrets. And it's, one of the golden rules is don't store secrets on the phone, on a mobile client. Well, yeah, but you're going to have to in this case. And there is a really good API called the Protected Data API. Protected Data, otherwise, what is it otherwise known as? I forget, it's another name for it, but Protected Data is the API. What this does is a really great way of just encrypting something, but what the problem with this is a chicken and egg problem with encryption. Every single form of encryption ever devised needs an encryption key in order to do the encryption with. And, of course, the encryption key is just as secure, is actually more secure than the data that you're securing with it. So you've got to save the key safely as well. So what do you do with that? Encrypt the key with another key? You see, where does this end? Well, what protected data does, yes, what it does is it creates a key internally on the phone, and it's a machine key. It's owned by the OS, a secure part of the OS. The OS knows about this key, it derives it, and it maintains it. And there's nobody, absolutely nobody, it will ever reveal that key to. So what that means is that anything you encrypt on that machine, and this works exactly the same on Windows as well, big Windows, anything you encrypt on that machine can be decrypted on that same machine. But as soon as you remove it off that machine, or you take it away, try and, you break open the RAM and the flash, and you manage to figure out where it is and extract it, it's going to be useless to you, because you will never find that key. So protected data is a safe way of storing stuff like credentials on the phone. So this is how you save stuff, credentials away, into a file. And this is how you decrypt it. So there's protected data.unprotect. So those are the pair of methods, and these slides really are just a nice little, another little addition to your networking toolkit to enable you just to handle the storage and retrieval of credentials securely. Now, I'm not going to show you that, but that's all the reference for you. Right. I'm going to go delving into another different part of my toolkit now and change tack a little bit. And talk a little bit about SkyDrive. Because SkyDrive is quite nice, because we've got a great API to access the cloud, and you can actually add a lot of value to your phone apps by storing stuff in the cloud. You could back up some users' data. Good friend of mine, Ginny, an MVP, she's got a password vault app on Windows Phone, highly recommended. And you can back up the vault up to the cloud and store it in SkyDrive. But the other thing that's really interesting from an app developer's point of view is that it's storage in the cloud that is free for you as an app developer. That's a nice thing, because actually the user owns that storage. It's their SkyDrive. So obviously you've got to give them the choice in your app as to whether you want to store data up there. That would be the right thing to do. But if they then, it's also a nice way, instead of you having to purchase, and I shouldn't be saying this as a Microsoft employee, to avoid spending money with Microsoft and actually getting some Azure storage up there, you could instead allow the user to use their SkyDrive storage. But what it does allow you to do is this nice connected app idea. This idea that you can have versions of your app running on a Windows 8 tablet and another version running on your Windows Phone 8 device. And if you've got some kind of multi-step task or something that involves, something you come back to it later on, you could start it on one device, you store the state up in SkyDrive, and then it doesn't matter which device, you then go out of the house and you leave your tablet behind, you pick up your phone, and then half an hour later you open up the app, the companion app on the phone, and you can access the same data and can pick up where you left off. And at a small level, things like PowerPoint does this at the moment with in Office, in that you can be on slide 23, editing it on one PC, and then you go back and you open it from SkyDrive on a different PC, and it knows where you were, and it puts you back on slide 23. And all of these little things, they're subtle, but they're really good value to your users. And it turns out it's quite easy to program as well. So there's an SDK. You need to go off to msdn.microsoft.com, off to the live SDK downloads. And you'll notice also there are SDKs for Android and iOS. So this is definitely not just for connected experiences with our platform. So we're embracing competitors' ones as well. And you also need, for your app, you'll need a Live Connect client ID. So you go to https://manage.dev.live.com/applications. You sign in there and create yourself a new application. That will give you back a client ID and a client secret. You'll need to, there's a radio button. As you see there on the image of the web page, you just need to click yes under mobile client app. If you say no, it will ask you for, it assumes you're a web application. It will ask other stuff about callback URIs and things. And then you create your app. You need to add a reference to, you've installed the SDK. You add a reference to Microsoft.live and Microsoft.live.controls. There is a sign-in control, which you can add to your toolbox optionally. And then you write a bit of code. And the first time the user runs your app, they will see a screen like this, which is just, I'm sure you've all seen these things where, with apps that authenticate against Twitter and this sort of thing. This is the same thing, but what it is you're getting the user's permission to use SkyDrive. And this is all provided for you out of the box. You don't have to code this. It's just a standard warning page, and the user has to say, yep, I'm good with that. And the best way of showing you, I'm not going to dig deeply into code on this one. I just want to show you the sample applications to give you a flavor for what it is you can do. Go and find the solution, and then bring you in. So this is the sample app. You get a very rich sample app in the SDK. Actually, this is a solution containing 5 projects. And I'm going to do this on, I'm actually going to do this, I've got my core concepts app here. And this one, I'm going to do it on a real device, just so that I can avoid showing you my password, basically, which is this guy. So first of all, the core concepts application, I'm going to run it. You should be seeing this device here. Oh, not that one. Okay, so deployment failed. Let's just try that again. Oh, yeah, it's just because I was too slow in taking the lock screen up. So that's deploying the application. Should start up in a minute. So this is, like I said, as a sample app. This is the sign-in control you get. So you can change the icon and the wording on that. This is the default rendering of it. So obviously, you'll first of all need to sign in to SkyDrive in your application. And here I'm going to put in my own Microsoft account. So hotmail.com. And this is where I'm just going to do this so you don't figure out. Oh! God damn. Does anybody know my password? There we go. Okay, that's signed in. So this is the standard page you'll see. Do you want to give permission? And I say, yeah, I'm good with that. And now what it's going to do now, well, this sample app, you can browse what's in SkyDrive. So first of all, I'm going to browse SkyDrive, see all the files and folders that are sitting on my SkyDrive. Many years of work here, all sorts of jump start, live, and this sort of thing. So you can see I could drill down. I'm not going to bother in a moment. But if I go back, there was also an upload file to SkyDrive. So I'm going to upload a file, and there's two choices. I can go and select a picture or select a file. Actually, before I'm going to do that, I think I'll take a picture of you very beautiful people out there, and then we'll send that up. There we go. Thank you so much. I will destroy this afterwards, of course. We go back, and then select a picture. Go off to camera roll. There's the one, the picture I've just taken. It's now uploading it to SkyDrive. I'm just going to wait for the full information for that operation to complete. There we go. File uploaded. So that's uploaded to SkyDrive. If I come out of the app again, you can sign out, but you'll see there that what's it called? Core Concepts. Start it up again, and of course it won't ask you to sign in again, because actually it saves your credentials, stores them securely, does kind of what I was showing on the previous slides, and you're straight into SkyDrive now. And on Windows 8 you don't even have to sign in, because it's more of a single sign-on experience. So we can browse SkyDrive, and we now should see at the bottom, should see that that image I've just uploaded is the bottom one. Actually, there's two images. And just to prove the point, let's go off to my SkyDrive folder. Go to skydrive.com. So here's my SkyDrive, and down there at the bottom, there's the picture I just took. Great. Well, it's not a great picture actually. But there you go. So there's that there. Now, also in this solution, like I said, there's a bunch of others. Almost the best one, that's kind of the basics, and you can look at that. But the best solution is this one. Set that as stop it running. Set this one as the startup project. Why this is the best one is because this one uses the Windows Phone 8 background transfer service to do the transfers for you. So the background transfer service, if you haven't come across this before, allows you to ask the OS to transfer a file for you, or files. So you just initiate the, you sort of register the request and leave the OS to get on with it. Your app can close, and the OS will just take care of it. So it's a really great way of making sure that your transfer is complete, and it just carries on. So this, I'm going to run that one now on the device. And I shall have to sign in again, I'm afraid, because it's a different app, this one. So sign in on this one. Put my credentials in. At hotmail.com, and then I shall again just put that in. Sign in. So again, we get the you need to give permission for this app to use it. And now I can upload files, and I can download files using the background transfer sample. So first of all, I'm going to download to this app that image that I just uploaded to SkyDrive. So first of all, these are all the folders in SkyDrive. here, and down at the bottom there's two pictures. So this is the picture. I'm going to download that to the phone. I'm going to wait and let it do it. So and there we are, it's downloaded. That was pretty quick. That's good. So there we go. That's now on the phone. And I'm going to now go over to SkyDrive folder again and just delete it off SkyDrive. So it's gone off my SkyDrive folder in the cloud. But of course I've got a copy of it down on the phone. So back to the app. I can now upload, and I'm going to drill down. When you do use the file transfer service, everything happens into this folder called Shared Transfers. So there is the image I downloaded before that's stored on the phone. I'm now going to send it back again, but this time I'm going to close the app as soon as I start the transfer. So I'm selecting the file. Upload is going to register the request with the background transfer service. It's underway, and then I'm going to close the app. I wasn't quite quick enough, but it's actually, normally I do this, and the network's so slow and rubbishy that I can close it in quickly enough. And over here, obviously, that transfer should have worked, and there you go. There's the image back on SkyDrive again. That one, by the way, is the speaker workroom a bit earlier when I was just checking this was still working. So there's loads of stuff in there. Like I said, I'm not going to drill into any of the code, but just to whet your appetite about some of the cool stuff you can do, and it's really quite simple to program. All right. Oh gosh, yes, this one. Yeah, okay, accessing local services from the emulator. Have any of you grappled with this one? Yeah, okay. So the problem here, let me rephrase that. The opportunity here, the problem here is, in Windows Phone 7, we had an emulator, and it used virtual PC technology, which was actually, it was hosted by the host PC, and it kind of had a shared networking model. So and they did this sort of nasty little convenience hack, which is very, very convenient, that you could actually make calls in your code, in your client code, running on the emulator to a local host address, which actually was a service running on your PC, and it would work. Very simple, and you didn't even have to think about it. But if you just take a step back, you think, well, actually, that shouldn't have worked. Because localhost means the same machine where the application is running. So the web server's not on the phone, it's on the PC. So in Windows Phone 8, we've got a whole new emulator, which is a full Hyper-V virtual machine. And it virtualizes right down to the hardware. It's a completely separate computer. So this localhost hack doesn't work anymore. So in actual fact, you could say they've kind of fixed the kind of dirty hack. But it does make life a little bit harder from a developer point of view. In actual fact, in terms of your client software, in your code that you're writing, it's no big deal, because all you'd need to do is, instead of putting HTTP whack localhost, you just put the proper IP address or the host name where the service is running. Easy, huh? Well, yeah, that bit's easy. The difficulty comes when you're creating your own test services running on your PC, because this is what the scenario we're talking about here. So on localhost, here we are, we want to create some kind of a service or a website or something that we want to access from our emulator. And the problem here is that in Visual Studio 2012, they've brought in this very nice new web server called IIS Express, which is there because in a lot of enterprise-level development shops, there was a lot of disquiet about having developer PCs and developer accounts running with admin privileges, which is what you need if you are working with real IIS. So if you want to work with IIS Express, which you don't need administrator privileges for, that's great. And if you're doing ASP.NET or web development in Visual Studio 2012, everything runs off IIS Express, and it's brilliant because it is the same as IIS 8 in terms of its functionality and everything, but you don't need privileges to run it. But it's a complete pain if you want to access a service running on IIS Express from a remote machine, because remote access is disabled by default. This is the problem. So if we were to say, take an example of creating a little website as a simple example, but an OData service or a web service, WCF service, this is all the same kind of principles. If we're going to create a website, so fine, you go into the new project, you create yourself an ASP.MVC project, and of course you run that in the browser, you just run it, and that will be running on, what it'll do is it will run it on localhost, on the browser, running on your PC, and it will give it some arbitrary dynamically allocated port number, 18009 in this case. So then you have to go in and do some nimble footwork in order to be able to allow that website to be accessed from a remote machine. So you need to, first of all, there's a file called applicationhost.config. If you go into My Documents, there's a folder in there called IIS Express, and in there's a folder called config, and in there you'll find this file, applicationhost.config. And in there, you edit that, it's just it's a config file. You edit that, you'll find an entry, there's a site section with an entry for every single one of the sites you've ever created in Visual Studio 2012. And including down at the bottom will be the site you've just created. And it will have an address, a binding statement like this, where it'll say binding information is port, the random number port that it gave you, and then localhost. And you just need to edit that and replace localhost with your proper host name. And then, well, I've said on this slide, you can remove your website from the solution and add it back in. In actual fact, it's much simpler just to close the solution and reopen it. And we're still not quite there. So that's the first stage. What you've done here is that you have you're allowing requests to come into this website using the host name rather than localhost. But you also need to do, well, first of all, actually, the wrong way around. First of all, that command in the middle. You need to open a command prompt with admin privileges. You need to do net share http add URL ACL, URL equals http colon, your PC name and the port. So what you're doing here is you're making a URL registration for that. You're allowing access to that URI from remote machines. And then you also need to open that port on the firewall, of course. So those two commands need executing. So, bundle of fun. I'll do that in a practical sense so that you can see how that works. Let's go off to Visual Studio. I'm going to go a file, new project. Let's create ourselves a Visual C#, a web one. It's an ASP.NET MVC4 web application. I'll accept the default name. So, yeah, mobile application. So we'll create ourselves a little website and building the project for us, adding all that ASP.NET goodness into it. And we've got a ready-to-go website which I can test in Internet Explorer on my box. And you'll see that it is running on localhost port. It's given us this port 2814. And there is our website. Now, over on the phone, the emulator, we can go off and there's the default settings thing, and then we want to try and go off to the server. We know localhost doesn't work, so this machine is called Rockstar, and the port is 2814, and of course that won't work because we haven't done anything yet. Can't find it. So we need to fix this up. So what we need to do is go off to My Documents, IIS Express, config, edit this guy, and we go down and there's loads of stuff. And then here's the website section. These are all the websites that are created on this machine. Not that many, actually. And here's the binding protocol for that new site I've just created. There's the site, see TechEd MVC Application 2. So I'm going to change this. Instead of being localhost, I'm going to change that to the true name, the host name of this machine. Save the changes. Then we're going to, I'm just going to close the solution and reopen it again. And if I try and run it now, you get an error box comes up. It says, unable to launch the web server, failed to register URL Rockstar colon 2814 for that site. So this is where we have to slip into that command prompt. Run as admin, say yes, and then I've got a couple of commands I need to do, which, so first of all, there's the net share HTTP add. I'm going to add a URL ACL, and I'm going to say URL equals HTTP, whack, and then it's rockstar : 2814 was the port. Then say user equals everyone. URL reservation successfully added, and then the other thing I want to do is net share add firewall. I could probably write a script to do this if I knew how. Firewall add rule name equals IIS Express non SSL, which is the name of it. It's all good fun, this, hey? Action equals allow. So we're going to allow it through, and it's going to be a protocol or equals TCP, and direction equals in, and the local port number equals 2814. Okay, it says. So there we go. Now, not only can I run it in Internet Explorer, it will always come up as localhost by default, but in actual fact, if I change that now to Rockstar, it finds the site, and over here, I can refresh that, and it finds the site. So there you go. So that was easy, wasn't it? Yeah, no, it's not. But at least shows you what you have to do to overcome these barriers to getting connection between the two. Right, I've got a little bit of time left, so we're going to now dive into, very briefly, the fun world of NFC and Bluetooth. So this is local communication with the Windows Phone 8. So it's networking, but not kind of the same as we've been talking about to now. So, but this is just for a little bit of diversion and interest. So we can now use Bluetooth for near-field communication. So we're up to like 10 meters. And we can use NFC, which is for connections between where they're only a few centimeters apart. So yeah, first of all, Bluetooth, short-range wireless communication technology. Yeah, up to 10 meters roughly. And we've got two flavors we can use. App to device, where the device is something like, a robot or a helicopter or something like that. And that must be paired with the phone, and we can connect to that, and we can talk to it and control it. And I haven't got a demo of that. I haven't got any robots or anything, I'm afraid. Or you can use app to app. And this is quite interesting because an instance of your app running on one phone can discover another copy of itself on a phone within 10 meters, and they can start up a Bluetooth connection and can communicate. And with that one, the two phones don't need to be paired or anything, so it's very lightweight and easy to use. The NFC one, though, is this is where you got between 3 or 4 centimeters. It can be transferred up to, yeah, that's definitely an up to 424 kilobits per second. In practice, you'll be lucky to get a tenth of that. And there's no real security to this model because it's assumed that this is absolutely intentional because the devices are actually touched together. There's a very funny video on YouTube of ways to exchange with NFC. We're doing like the high five, and you can put your phones in your back pocket and do this surreptitious kind of, tapping like that. So you can use NFC for connecting devices together. You can use it as a tap to connect as an initial way of setting up a Bluetooth or a Wi-Fi connection. So you can then do something with a bit higher bandwidth. Or you can read smart tags on posters, or you can actually simply exchange strings or URIs or things like V-cards, contact things. And that actually works very nicely today between Windows phones and Android devices, for example. iPhones do not have NFC. So yeah, so I've already said a simple transfer of a message or used to configure a connection between the two. So first of all, I'm going to look at that one, tapping to connect to set up a higher bandwidth connection. So first of all, you need to, the proximity to device.getDefault is the API that says, have I got NFC on this phone? Because not all of them have got NFC, so you need to check whether it's there or not. So if the device is not, that proximity device returns an object, then we know we've got NFC support. And then what you're going to do, if you're going to use this NFC tap to connect, you'll need to hook up a triggered connection state changed event, and then you start finding peer apps. You can also add in identities of Windows 8 machines, so you can use this to connect a phone to a Windows 8 tablet as well, so you can have communication going on over Wi-Fi or Bluetooth there. That triggered connection state, you'll get loads of event calls come back from it as it goes through different stages. Listening, peer found, connecting. The important one, though, is that completed one. When you've got completed, you know you've got a good connection set up between the two. And then what you get out of that in the args.doc socket parameter of that triggered connection state change, that event args, is a stream socket. A stream socket is something that you can just read and write to in order to communicate between the two applications. And you can use Bluetooth or infrastructure for this. Now, I've got a little demo here. And I haven't got a lot of time, so I'm just going to show you how it. I'm going to talk through it rather than I was going to step through some code, but I'll keep this short so we can move on. So this is the sample application. Show you the right thing, that might help. This is the sample application that's in the SDK. SDK Bluetooth. This is a kind of a chat thing, and on this one as well. So at the moment, you can just say to join. And at this point, this is looking for other Bluetooth devices that are also looking for, they're searching at the same time. They're not looking at the moment, so it's not found anybody. This one is now going to join it. It's going to look for peers, and it's found the other guy. So it can now connect to the other guy. And on this, you're going to get a triggered connection state thing. He says, oh, it was refused. Oh, right, okay. Yes, I want to chat with it. Right, now they've joined connection, so I can go sort of, hello, and send it over, and it appears over here, and that one can chat back again. And now we're talking Bluetooth. This is Bluetooth peer-to-peer. Now, I've got another example, the actual NFC tap to connect, which is, this is actually an app that's in the store. This is a Bluetooth game. It's not tic-tac-toe. So actually, in fact, I can stop that one. And on here, I'm going to start the game. It says tap to connect. So now I can tap the two devices together. This one says open app. Someone wants to use tic-tac-toe Bluetooth. Can you see that all right? With you. So you say open the app. So the NFC was used to set up the connection, but now they're Bluetoothed. So they can communicate with each other, and we can play a game. So there we are. There's playing O, and O's a bit stupid, so he plays there, and then X goes there and go, yeah, we're great. Now, the other interesting thing about this is if I let's just quickly switch back to the slides. Because you can also tap and share an app. So that one, if I remove this app from here, uninstall it. So this app isn't even on this phone anymore. This app has got the option, you can do this from the programs menu as well, but I've also got this tap to share an app. So I can now, what we're doing here is writing the store URI, and now this one says launch store. Someone finds something they thought you might like. So it goes straight off to the store, and it finds the app. It's actually the wrong app, because it's got the wrong URI in it. But you get the idea, because this is a pre-release, and the app wasn't published before now. But the code to do that is simply this. All you need to do is you get your proximity device, and then when you go to that tap to share screen, you start publishing this URI message down at the bottom there, and it's this Zune::navigate. And that app ID is the app ID of your app in the store. So you can actually tap phones together and take them straight to the store so that they can actually go and find your app, install it. So it's another nice way of exchanging, of getting your app onto other phones. So that's it. We've been through all the content. This is all the stuff we've gone. I hope after all of that you are feeling like you're fledgling Windows Phone networking gurus. Now, I'm going to run through just a couple of slides to wrap up. But if you filled in all those cards, can you pass them all to the ends of the row? And my lovely assistant out there, thank you, will collect them. And then I shall pick one card, and somebody will be the lucky winner of a phone. So while that's happening, I should just walk through these last through slides. A couple of sessions that are related to this. Please come and see me talk about SQLite database on Thursday morning. And then there's the great session coming up next. Matthias Shapiro built it once for both, about writing code and designing for Windows 8 and Windows Phone 8. I shall be Ask the Experts tonight, so please come and find me. We've got packed sessions this week. On Monday, we saw some yesterday. We're about halfway through Tuesday at the moment. We've got all those sessions coming through on Wednesday, and then 3 more on Thursday. So I hope we'll see you in some more phone sessions as well. And we've got some great hands-on labs available for you to go and actually get some hands-on practice with all this stuff. Okay, so have we got all these collected? We're nearly there. We good? Okay. So let's find the lucky winner. Throw them up in the air, I think so. All right, here we go. Okay, the lucky winner is, I can't read it, Ed Longer, sorry. Who is the winner? There we go at the back. Congratulations. You'd like to come up, please accept your phone. So commiserations for the rest of you, but please come down to our stand. We're giving away phones every hour, and you all need to do is sit through one of the presentations or wear one of the great hats and that sort of thing, so there's other opportunities. But thank you very much.